So I want you doing it. Are you new today? Then you should be good by today. Okay, don't forget, have you got a speaker covered up with your jacket? No. Okay, good. You're perfect. Okay, welcome back everyone to Math 131. We are now on Lecture 2. We started yesterday with difference equations, and we're really looking at textbook sections or supplement sections 10.1, 10.2, and I really slid in on you some of 10.4. They kind of go together. I'm working it all together, and then we'll come back and pick up with 10.3. Not every little thing in 10.1 has been done yet, not every little thing in 10.2, but we're sort of doing it all together. At the end of Lecture 1, we were looking at a problem we did not have time to finish, so we'll work on that today and kind of clean that up. And then we are going to buy a house or a car, and before we started the taping today, this class prefers a car today over a house, so we're going to buy a car. So our question is going to be how much you can afford, so we'll decide what the payments are going to be. We know what we can afford, we know what the monthly payments we can afford, what price loan can we get, what size car can we go out and purchase. That's usually the direction you should go. You should decide how much you're going to make in monthly payments and then go to find the car. Don't look at the cars you can't afford. All right, then we're going to go to the textbook, and this is a problem that's not related to money. I think it's a population problem. Page 384 is in the exercises of number 20 to show you that even though I'm just doing a lot with money because that's fun, it certainly works for any kind of exponential growth or decay, a compounded rate like compounded monthly, annually, anything that's an exponential growth or decay. We'll have to review a little algebra using logarithms to solve for n. You're experts in pre-calculus, so this would be a half a second review. And then I want to talk about graphing the solutions to difference equations. This plotting points is actually in section 10.1. We're just going to set up a grid. When n is 1, what is the value of the function? So we're just plotting points. But the thing that you really want to do is from section 10.3, where we're going to learn to graph without plotting points. And the reason is, once we set up our difference equation, if we can analyze what the graph is going to look like, we can make long-term decisions. For example, if we have a graph that is going to level off approaching a certain number, for example, you have a pond with some fish in it, well, the pond can only sustain so many fish with oxygen and food before they start dying out. So if you know what the pond will sustain, you can see how the growth will take place. Or if you have some little bacteria that's growing, over a short period of time, it's going to go like, oops, I'm doing it backwards for you, aren't I? It's going to grow like this forever and ever and ever. That's an exponential growth. But if it starts to level off, we have what is called an asymptote there. So we can discuss the long-term behavior. Or if we have a little town that everybody's leaving because there's no industry and people are dying out, that would be a curve that's going down towards zero, right? I don't think we could have any negative people. So we're going to learn in section 10.3 how you look at the difference equation and your y sub 0 and have an idea what the graph looks like. And hopefully you read through that because I asked you to go ahead and read through 10.1, 10.2, 10.3, 10.4 last night. All right, so let's first look at the problem. Any questions before we start? Okay, be sure you're working on your WebAssigns. This was the problem at the end of class yesterday that we got in a hurry with. We're going to deposit $2,000, and that is our y sub 0. Then at the end of each month, we're going to make deposits of $250. So when n is 2, that is the second month that we're saving, we're going to add another $250. So we see a pattern of the same thing happening month after month after month. So the beauty of the difference equation is we'll set up a general formula, and then we're able to generate terms, and we also have a solution. Okay, so once we saw the process of what was happening, we know the new balance, which is y sub n plus 1, is equal to the previous balance of that period, of that particular period, your y sub n, plus, and what was this part right here? That was the interest on your y sub n. The formula is I equals P R T, the present value for that particular period. P is your y sub n. We had an interest rate of 0.08 that I wrote down incorrectly yesterday because I was hung on the 6%. Thank you for correcting me. And then time in this formula is always in terms of years. So 1 month is 1/12 of a year. All right, so that's your y sub n, the interest on your y sub n, and then you're making your deposit of $250 at the end. So that describes what happens each period. Is there a question that far, anybody? Okay, then after class, because we got in a hurry, I got the little signal that my time was running out, was where did this 1.0067 come from? Remember, this is 1 y sub n plus, now let's do 0.08 divided by 12. Can you see it on my calculator? 0.08 divided by 12 is 0.00667. I don't know how to, oh, you can see it good. All right. And then, of course, that's going to be 0.006666 whatever y sub n, and you'll be adding to that 1 plus that number. So when you added 1 to it, you get your 1.006666, which I rounded to 4 decimal places, and that's where I'm going to ask you to go. Okay? All right. What did we call this thing right here? Difference equation. And from the difference equation, I can iterate terms. I can find y sub 1. How do I find y sub 1 if I have this difference equation? We're going to substitute in, that's exactly right. Let me see if I can do this with blue. Okay, our difference equation is y sub n plus 1 equals 1.0067 plus 250. All right, and if you start out with y sub 0 equals 2,000, then when I want to find y sub 1, remember it's got to fit this formula exactly. So in this formula, this is going to be y sub 0 plus 1 to make it add up to the 1. So the n in my formula is going to match up with the 0 there. So we have, oops, I left my y sub n out. Okay, we have y sub 1 equals 1.0067 times y sub n. The y sub n is y sub 0 plus 250, which is 1.0067 times 2,000 plus 250. And let's see if we can do that on our calculator. Let's turn it on. 1.0067 times 2,000 plus 250. And at the end of the first month, that is how much I would expect to be in my account. 40. Make it dollars and cents. Okay, so y sub 1 is 2263.40. And let's just go one more step. Y sub 2, to make it fit the formula, would be y sub 1 plus 1. So n is going to be matching up to that 1 right there. So we will have 1.0067 y sub 1 plus 250. 1.0067 y sub 1 is 2263.40 plus 250. And if you never erase your calculator, it's going to be nice. That way you don't have to keep typing so much in. I'll just multiply that now times 1.0067 and add 250 to it. And that should be 2528.56. Everybody good? Okay. I think I did this on the spreadsheet right before we came on. Oh, yes. Oh, no. 2,000. Put in 250. I might have the wrong interest rate here. Oh, yeah, I put 6%. Can you see at the top of the formula bar? I put 6 because I was so hung on 6%. Let's see if I can change that. We're at already 8%? 8%. Okay. And let's see, make sure I fill that down. How far did I go? All right, I quit on this one early. Fill down. Oops. Okay, I messed up my whole spreadsheet apparently. All right, there's the 2263. B5.08 divided by 12, 250. Didn't fill this down. Okay, if this doesn't work, I'm going to quit. I'm just playing. Are we together now? Yeah, somewhat. I must have hit something in here must not be exactly right. Okay, or either I did an arithmetic error. Oh, I rounded I'm sure the computer is not rounding like I did. This has 42 cents. I have 56 cents. It kept all the decimal places. Okay? All right. We know how to generate the terms. Now, what was the question, though? At the end of 40 years, how much is in our account? All right. So I could do the spreadsheet, carry it down for how many periods? How long is a period? A month. I'm doing it for 40 years. So what is N going to be equal to? 40 times 12, which is what, 480? Okay, remember N is your periods, and if we're doing it monthly, we're talking about how many months are here. All right, so we're going to go to the solution to our difference equation because we don't want to do this for 480 times, correct? We want to get right to the answer. All right, let me write down the difference equation again. Y sub n plus 1 equals 1.0067, y sub n plus 250. Okay, and again, we're off a little bit because really it's 0.00 with all the 6 repeating, and over a long period of time it does start to make a difference. All right, and we know that y sub 0 is equal to 2,000. All right, without looking down, I want everybody looking at me, and I want to hear what the solution is. B.
1 minus A plus.
Don't look down. Y sub 0.
Minus B over 1 minus A.
Very good, very good, very good. All right, so let's go all of our parts here. We're looking how much is in the account after 40 years. So N is 480. A is what? 1.0067. Remember, it's A, Y sub n plus B. B is 250. Go ahead and figure out what B over 1 minus A is, because if you'll do this ahead of time and then just put it in your formula, it's just going to be easier and you make less mistakes. 250 over 1 minus 1.0067. And double check me on the calculator. Make sure I'm not punching in anything wrong. That will be 250 divided by a negative 0.0067. And that comes out to be pretty close to, oops, I'm going to have to put on my glasses. Is that 37? Yep. 37313. I'm going to keep 4 decimal places, that's negative, till the final answer. 4328. Probably should keep more because after 40 years we're going to have a lot of money. Okay, but we'll stop right there. 4328. This is just a good approximation anyway, because your interest rate will not remain the 8% really for 40 years. So you're really approximating. All right, so when I say y sub 48, say again, what am I looking for when I say y sub 48? 480, sorry, y sub 480. What is that going to be? The balance at the end of 480 periods. Okay, that is the amount. All right, so we'll have negative 37313.4328 plus y sub 0 is 2,000 minus a negative. Everybody see that? That becomes plus 37313.4328 times 1.0067 raised to the 480th power. Is that correct, everybody? Okay, work ahead of me. Remember, you take care of exponents first. Everybody raise it to the 480th power and get something like 24.66. Okay. So we do the exponents first, and now we'll do the multiplication. That's not what you got? Am I hearing that? Then I'm sure it's your calculator. All right, did you guys get 932,244 and about 81 cents? Yes. All right, let's see what we did here. We put $2,000 in an account. We put $250 in 480 times. Our account earned 8% compounded monthly, and this is how much money is in our account. Aren't you a little bit curious about how much interest you earned? How do you figure out how much interest you earned on your account?
250 times 480 and subtract that out, and then subtract 2,000 out, and then all the rest of the money you earned is interest.
Okay, exactly right. You're using common sense. Interest is the difference between what you put in and you pull out, right? Because the rest, it just worked for you. So you put in 2,000, and then you put in 250, 480 times. That's how much you put in. And the amount now that you can pull out is 932,244.81 about. So let's see if I can figure out a way on the calculator to do this. Okay, I made my answer negative, and I'm going to add to that 2,000, and I'm going to add to that 250 times 480. I think the calculator will do multiplication for me. Pretty sure it will. Oops. No, it didn't. Oh, why was my answer negative? I did it backwards. You can pull out more than you put in, right? Make this part negative. This is how much I can pull out. This is what I put in. I put in a lot less than I can pull out. So let me try that again. All right, so we have 932 244.81. And from that, I'm going to subtract 2,000. And I'm going to subtract 250 times 480. Okay. And so what we earned in interest by keeping our hands off that account was a nice $810,000, 244.81. $810,244.81 is about what we earned in interest by letting your money work for you. Okay? All right. Any questions? That's nice, isn't it? It's an exponential growth. You're earning money, interest on interest. And what happens is the curve starts out slowly, and then it starts to go like this. But what happens is people get money like this, and what happens? Take it out, start here again, and then what happens? You have children. Let's go back this way with the children. Okay, and then you start again. You know, but if you would put it in a retirement account where you can't put your little hands on it, leave it there long enough, it just starts going crazy, earning interest for you. And get one of those tax deferred, or you might want a Roth IRA. There's all kinds of things to consider. All right, that was great fun, right? Okay, let's buy a car. Oh, you know what? I only did the spreadsheet through, I started at 4. So I only did the spreadsheet through 3 years. Even though it's showing you a 40 right here, I didn't start till sale number 4. So I did it for 36 months. I would need to carry that all the way to 480. And I didn't want to do all that fill down. But you can do it. You will have fun. All right, and again, this is off a little bit because I rounded my decimal to 4 places when I did 8 divided by 12. But you're going to be pretty close. All right, let's buy a car. Buy a car. All right, before we started the video, we said 9% interest is not unrealistic on a car loan, especially over periods of time. So we're going to do 9% compounded monthly. Now, when you hear 9%, that really is an annual rate partitioned monthly. 9% monthly. All right, and how many months are we going to pay on this car?
4 years. 48.
Okay, 4 years, get a 4-year loan. Okay, 4-year loan with monthly payments. All right, and let's decide how much we can afford to pay every month. That's the way you decide before you look at these cars that look a little too shiny that you'd like to have. How much can we afford monthly in car payments? $350? $700? We're going to find out where you work. All right. Monthly payments, I'm going to compromise because I heard $350, $250, and I'm going to forget your $700. I'm going to compromise with the $300 every month. Yeah, that $700 is about to blow me away. I'd hate to be making $700. Okay. All right, so what I need you, we're going to buy a car. The question is, how much can we borrow? And then you can decide if you have any down payment to put on top of that, and that'll tell you the price of the car. How much can we borrow so that we'll have this loan paid off at the end of 4 years? All right, draw your time diagram and enjoy doing this with your neighbor. Set up your difference equation, and then I'll catch up with you. What you're looking for, how much can you borrow? What's the symbol going to be for that? On your time diagram. When you borrow money, when do you borrow it? At the beginning. So y sub 0 is what you need to find out in this problem. Excellent. Right? Y sub 0, we're going to borrow some money, and then we're going to make payments at the end of every month. Got it? Excuse me?
So D would be your payments?
It is going to be your payments. The B is going to be your payments. Good. So your Y sub 0 is your unknown. Your handwriting's really nice. Did I already tell you that?
No, ma'am.
N is in terms of what? Months. So when you're looking for a T, how are you going to write T? How do you express your time? 1/12. Well, somebody tell me what Y sub 48 is going to be equal to. What, when I ask you what is Y sub 1 or Y sub 2 in words, what would Y sub 48 be? Okay, but in words relative to the problem. What's Y sub 1 relative to the problem? You know, it is the...
When you need to pay back the loan.
Okay, so Y sub 1 would be the balance after the first payment, right? So what would Y sub 48 be?
When you have to pay back the loan. The end of the 4 years.
Okay, so at the end of the 4 years, just after you've made the 48th payment, what is the balance of your loan going to be?
0.
Yes, because you've paid off your loan. So Y sub 48 is going to be 0, correct? Y sub 48 is going to be 0 because you've been making payments and you've paid off your loan. Now, usually we round payments up to the next cent, and the bank will send you this little notice, and they'll say, congratulations, your final payment is going to be 30 cents less. And you think, oh, they really like me. But what happened was they rounded up your payments so your final payment will be a little smaller. Because they know you would hate them if they send you a little note and say, we're happy to announce your loan's almost over, but your final payment is $3 more. And you would, you know, go trucking down the bank and asking what's going on. But if they say it's less, then everybody's so happy. Okay. All right, we got our difference equation set up. All right, so Y sub n plus 1 equals. Okay, so I can use a difference equation because the same thing is happening month after month after month. All right, so start me out. We'll put in every step. Y sub n plus 1 is going to be Y sub n plus, what happens in here? Interest. And I'm using the formula PRT, right, for interest. So what's it going to be? Y sub n times 0.09 times 1/12. All right, so that's the Y sub n. That's the interest on it. And then what's going to happen? Yes, we're making a payment now, so that's going to be minus instead of adding to it. When you have a savings account, you're adding to it. When you're making a payment, you're pulling it off because you're trying to reduce your loan. Okay? So 0.09, I purposely picked that because the arithmetic comes out easy. It's 0.0075, so Y sub n plus 1 is going to be what, everybody? 0.09 divided by 12 is 0.0075. 1.0075 Y sub n minus 300. 0.09 divided by 12 is 0.0075, so 1 Y sub n plus 0.0075 5 y sub n is 1.0075. Everybody good? All right, and we don't know what y sub 0 is. That's our question. All right, so clearly we can't sit here and generate terms because we don't even know what y sub 0 is. So we know, hey, let's use that solution to the difference equation and see if that won't help us out. All right, so let's go to the solution. Oops. Everybody good? Got it? Okay, so y sub n plus 1 equals 1.0075 y sub n minus 300, and our y sub 0 is unknown. All right. You're going to have this memorized shortly. Don't look down. I want to hear that solution again. Y sub n is what?
A plus y sub 0 minus
c over 1 minus a.
A to the.
Okay. And really this is when a is not equal to 1. But I'm not going to give you a problem where a is equal to 1 anyway. All right, so start plugging and chugging and see what we can get here. Notice when you do your b over 1 minus a, you're going to have a negative over a negative, which becomes a positive. You get positive 40,000. Okay. Let's start putting it in our equation. Y sub n equals 40,000 plus y sub 0 minus 40,000 times 1.0075 raised to the n. Okay, everybody good so far? Now, we're looking for y sub 0. The problem is I still have two other unknowns in here. I have an n that I don't know, and I have a y sub n. Was there any other very important information we were able to figure out in this problem? Okay, y sub 48 is 0, because we know that when we pay off a loan, the final balance should be 0 after 48 periods. Okay? So we're going to use the bit of information that y sub 48 is equal to 0, and that will get us down to one unknown in our equation. Let's take a guess before you figure it out. How much do you think you can borrow to have payments of $300 every month? All my good financial people here. How much? 2,000. I think you can probably do more than 2,000. 3 times 48 is going to be more than that. That's 12,000, and you can. All right, let's have fun and do it. Okay, when n is 48, we're going to have 0 equals 40,000 plus y sub 0 minus 40,000 times 1.0075 raised to the 48th. Okay, so I've inserted this very important piece of information here. All right, we're going to do a little algebra, and there's various ways you can do it, and I'm going to do it the way I see the most straightforward, easy way. What I'm going to do, remember how when you're solving an equation that's got an x, you try to get the x on a side by itself? All right, so here's the unknown with the y sub 0, so I'm going to try to get it on a side by itself. So the first thing I'm going to do is carry the 40,000 over. All right, there's various ways you can get there. I'm just going to try to show you just some algebra to get there. All right, so if you had an equation that had like x times 10, what would your next step be to get x by itself? The division. So we're going to divide both sides by this 1.0075 raised to the 48th, just like when you had something like 3 equals 10x, you divide both sides by 10. So this thing is multiplied times the expression that has the y sub 0. So we have minus 40,000 divided by 1.0075 raised to the 48th equals y sub 0 minus 40,000. Right, I divided both sides right here because it was multiplication. Everybody with me? It just looks ugly, but it's the same kind of algebra you've been doing. All right, now it's y sub 0 minus the 40,000. So how do you get y sub 0 on a side by itself? Yeah, add it to both sides. So y sub 0 equals 40,000. I added it over here, and then we got it minus 40,000 over 1.0075 raised to the 48th. Okay? Everybody good? All right, so let's just do the arithmetic. Everybody has their own ways of doing it. I usually start with the exponents and then flip it over and multiply it. I'm not sure how you do it. We better end up with about the same answer. And I'm not going to erase and rewrite, so I'm going to do it all in one step. I'm going to do 1.0075. I'm going to raise that to the 48th. And then I'm going to flip it over with that little 1 over x button, wherever it is on my calculator, right there on mine. Okay, and multiply that times a negative 40,000. So that expression right there should be that. I'm going to add to that 40,000. And we're not too far off on our guess. I got 12,055 and about 43 cents, 44 cents. Okay, it's about the price amount of the car loan we could borrow. Well, you want to keep all your decimals till the final answer, especially if you're trying to match up with WebAssign, because it has one formula that it does it. Yeah, I'm not going to worry. As long as you got all your steps there, keep about 4 decimal places and we're good. But if it's money, round to 2 in the end. Everybody good? Doing fine? All right, so you might consider a used car. That's right. Can't advertise here, though. All right. We're going to do a problem right out of the exercises, page 384, number 20. But I need to remind you some algebra real fast. Okay, our goal is on page 384, number 20. This is from the exercises in section 10.1, but it's not money, so I thought we'd see how population grows. All right, we need a little algebra review. Algebra review. Let's do an easy exponential equation. 2 to the x equals 32. How did you solve those algebraic equations? Okay. Okay, so you got like bases, and if the bases are the same, the exponents are equal. All right. What's another way you can solve this problem just in case you could not get like bases? What's another way to solve it? Yes, take the log of both sides. And I always just use natural log, but you could use common log. Natural log takes less letters to write. I'm calling it efficient, not lazy. All right, so you could take the natural log of both sides, and that's what you're going to have to do in our problems because you're not going to be able to get like bases. And then you had a property of logarithms. Your property in logarithms say that the log of a raised to the p is what? P times the natural log of a, and that's why you're using logarithms so that you can apply that property. So we get x times the natural log of 2 is equal to the natural log of 32. And then how do we solve for x? That's not a trick question. Yep. Natural log of 32 divided by natural log of 2. And we'll go to our calculator. Natural log of 32 divided by the natural log of 2. And there's your 5 right there. Okay, same answer. We were able to get light bases because I picked an easy problem, but I wanted to remind you that you can always take the natural log of both sides and apply your properties of logarithms. Okay? Everybody good? All right. So let's go to page 384 in the notes. And we're going to look at problem number 20. Let's see if we can zoom in on problem number 20. There we go. Good. All right. So everything we've done has really been playing with money, but this also applies to population growth or whatever. The population of a certain country is currently 70 million. All right, so we know we're going to be using a difference equation, and we're going to start out with 70 million. What symbol are you going to use to represent that 70 million? Y sub 0. Very good. Y sub 0. All right, so as we do this, we know Y sub 0 is 70, and this is going to be in terms of millions, so we don't have to really write out all those zeros. We'll just do 70, knowing the units are millions. But it is declining at a rate of 1% each year, owing to the excess of deaths over births. So more people, this must be an old town and everybody's dying out. Okay, so it's declining at a rate of 1% each year. So whatever the population is that year, they're expecting 1% to have 1% less at the end of that year. And then the next year, whatever you have, you're going to have 1% less. In addition, the country is losing 1 million people each year because people are getting out of town. Immigration. All right, let Y sub n be the population after n years. Find the difference equation. So this is section 10.1. They're not asking you to do anything but set up the difference equation. Of course, I always think it's much more fun to find out when everybody's going to be dead in that town. Okay? All right, so I'm going to add when is the population down to 0? When? All right? Okay, set up your difference equations very quickly. All right. Oops. Everybody got your difference equation? Was it too easy? I heard everybody say, yes, easy. Okay, this is page 384, problem number 20. All right, what did you say you did with the current population of 70 million? Y sub 0 is 70, and this is in terms of millions. And it's declining at a rate of 1% each year. All right, so at the end of, and this is going to be yearly, so N is going to be 1 year, and it's going to go down. It's going to go down. How do I tell you it goes down? I'll just write lose 1% each year. Okay? And then it says people are going to get out of town. So at the end of each year, 1 million, I'll just write negative 1 million leave. Okay, so here's n at 2. So y sub 1 is going to be how many people are left at the end of the first year. And then we're going to lose 1% again. Then another million are leaving the country. All right, and we're going to go from there. All right, so let's hear your y sub n plus 1, which is right here. Okay, so to go from y sub n plus 1 is going to be what?
1.01.
Okay, so let's do y sub n. And then what happens in here? Lose 1%. How are you going to write losing 1%? Minus 0.01 of y sub n. Y sub n is the size of your population, and you're going to lose 1%, correct? 0.01. Okay, and then what happens? Minus 1 million. It's going to go away. All right, so 1 y sub n minus 0.01 y sub n is what, 0.99 y sub n? 1 minus 0.01 minus 1. Okay, there's our difference equation. Does that make sense, everybody?
What's the minus 1 at the end?
Right here, that's the 1 million that's leaving town because there's no jobs. It said, in addition, the country is losing 1 million people each year because they want to leave. Okay, everybody good? All right, so this is all this problem asks you to find, but we're not happy. We want to know more. Okay? We want to know when is everybody going to be gone. So when means we're looking for n, correct? When will population equal 0? So we're looking for a y sub n equals 0, right? When will it be 0? Okay, so let's set up our solution so we can go to it. Y sub n equals, are you saying it in your brain? What's our solution?
Plus 0.
People minus a times a v m.
Yes. All right. And let's get our a is 0.99, b is negative 1, b over 1 minus a is negative 1 over 1 minus 0.99. We should be able to do this one in our head, but we're tired. Ooh. What's that, negative 100? I don't know why I'm having a mental block. Okay. B over 1 minus a is negative 100. All right, so let's put it in. We're going to solve for n. So y sub n is going to be 0 equals, and this is negative 100. Remember the units, it's millions anyway, plus y sub 0, we know what that is, 70, minus a negative 100 would be plus 100, correct? And a is 0.99, and we're going to raise that to the nth. Is that what everybody has? All right. Let's get the algebra steps together. 0 equals negative 100 plus 170 times 0.99 raised to the n. All right. I know I'm going to have to solve for n, so what are the steps getting there? Add 100 to both sides. Okay, I'm trying to get the factor with the n by itself. What's the next step? Divide by 170. And you can reduce this if you want to. But, hey, we got calculators. All right, what's the next step, everybody? I'm trying to get to that n, and it's up in the exponent. Take the natural log of both sides. Okay, I'm going to try to finish it on this page. All right, and the reason I took the natural log of the 0.99 to the n, it's going to allow me to use properties of logarithms. So I'll have the natural log of 100 over 170 equals, say it so you'll remember it, n times the natural log of 0.99. So n then will be the natural log of 100 over 170 divided by a natural log of 0.99. Okay? All right, anybody want to guess before we do it how long it would take this population to die out?
52.8.
You already worked it out.
That was a guess.
Oh, that was a very good guess. Right. All right, natural log, parentheses, 100 divided by 170 equals. And now we're going to divide that number by the natural log of 0.99. And it's going to take about 52.8. I'm just rounding it. What's the units here?
Million.
No, n is years. Okay, so if they expect that population to be gone in 52 years, there's not a whole lot of need to go build a lot of big highway systems and a lot more schools and stuff. So it helps them make a prediction how the population's, what's happening. Or they better bring in some industry and get going. All right, everybody good?
How come you didn't put a 70 million for y sub 0?
I did, right here.
70? I thought it was 70.
My units are millions.
Oh, okay.
And so when I used 100 here, that was really millions also.
Oh, okay.
So they'll be gone in about 52.8 years. All right, we are experts now in writing a difference equation and the solution to a difference equation and solving for any unknown part. For example, you could say, I am determined I'm going to borrow $200,000 to buy a house. And when you set up your difference equation, your B will be your unknown because that's going to be your payments, and you're going to solve for B. So you can solve for any part using a little bit of algebra. All right. We want to go into graphing now. Graphing. This will be parts of graphing. And this is going to be parts of 10.1. But it's mainly going to be 10.3, which is the part we're really interested in. All right, graphing difference equations. Difference equations. Okay, let's see if I still have this. Yeah. I'll just use this spreadsheet I already have here. All right, in section 10.1, what they're wanting you to do is to set up a grid, and along this axis put n, which is your periods. Okay? And this axis, which you've always called a y-axis, right? This is going to be your y sub n. It's going to be your value after n periods. All right, and since I already have this spreadsheet with the problem we did earlier, the beginning balance, 2,000, making your monthly deposits, and you got your ending balance here, I'm just going to plot some points just like you did in algebra. So we're going to mark off n at 1, 2, try to be fairly consistent with your units, 4, 5, 6. And I'm going to have to put a little break in the graph to start us with the 2,000 because that's our initial deposit. Can you see? Okay, and I'm just looking at these numbers, and they look like they're going up pretty good by 500s. So the next little place is going to be 2,500. The next one will be 3,000. The next one will be 3,500. The next one is 4,000, 4,500. Remember, your units on your y-axis have to be consistent. The units on your n-axis here will have to be consistent. And this is not going to be a perfect little graph, but graph paper is always nicer. Okay, this is a little break to indicate that I'm jumping and starting with 2,000 and then working up. All right, so I'm looking back at the spreadsheet where we know the ending balance represents our y sub n's. Let's see if I can, I just about lost your periods there, didn't I? So if I move it over just a little bit. Oops. There we go. All right, and we know that we begin our balance at the end of the 0 period with our 2,000, so we'll just make a little dot here. Okay, at the end of the first period, according to our spreadsheet, we had about $2,263.33. So y sub 1 is somewhere right here, and if you make your dot big enough, you're bound to hit it. All right, so that is the ordered pair 1, comma, then 2263.33. That's that little dot. And then the balance at the end is 2528, and that's going to be about right there. So that's the ordered pair 2252842. And then 3 is about 27. That's a little bit higher right there. All right, everybody got the feel for this? Let's see, I went all the way out to 6. At 6, by the time you get to 6, you're at 36, whatever. And that's about right there. Now, when you're plotting this in the beginning, it's looking almost like a straight line if you were going to connect the dots. But you will notice that as you start going further down, it starts jumping a lot quicker, I hope. And you're going to end up with a graph from a long distance that's going to start to look like this over a period of time. It's just going to grow like that. Okay, but in the beginning, you're not earning a whole lot of interest on interest, so it's kind of slow right in the beginning, and then it starts to go like this. All right, what am I trying to point out to this? When you're graphing a difference equation, it's dots. You're used to graphing functions for all real numbers. N is the numbers 0, 1, 2, 3, 4. So you're going to have dots on your graph. Okay? Everybody good on this? All right. Now let's go to section 10.3 that says, hey, we don't want to sit there and figure out every little value. We want to be able to just analyze what the graph is going to look like. So I call that graph analysis. So we're in section 10.3. Well, can't find it. Here we go. All right. So 10.3 is going to be graphing difference equations without plotting specific points. And the main reason you do this is so that you can discuss the long-term behavior. For example, the population we just did, the people were dying out, so there's no need to go spend billions of dollars on a new mighty road system. But if you have a population that's booming, you need to start thinking about more grocery stores, more highways, more schools, or whatever. What's happening in that situation. All right, so we're going to come up with we're going to use the difference equation, y sub n plus 1 equals a y sub n plus b. We're going to know what y sub 0, and from just this little bit of information right here, we're going to know what the graph looks like. All right. So before we jump into that, we need to make sure we understand some words. Terms related to graphs. We have terms that says our graph increases. decreases, or oscillates, or is constant. Okay, so is there two L's in oscillates? Yes. Okay. You just didn't see that other L there. All right, when you worked with algebra and you had a function that increased, what did it look like? Yep, went up. Okay, so two particular pictures of an increasing function. It might increase like this. That's a concave up, right? It might increase like this. Those are all increasing because each y value is bigger than the previous one. Increasing. All right, then you could have decreasing. I'll put that on this side. Decreasing. Decreasing coming down, like our population that just died out in the problem. Or we could also have decreasing that looks like this. Something like that. Okay, decreasing. What does a constant graph look like? Yep. Yep, horizontal line. You just like this. Okay, now let's think of a good example when you have a constant situation. You've heard old people say, I want to have enough money in savings to live off the interest so I don't have to predict when I'm going to die and run out of money, right? So a constant would be always living off the interest of your money. It would earn some interest, you take it, spend it, and you're back to the same amount. So every y sub 1, 2, 3, 4 is always going to be the same thing because you just pull off the interest every month and spend it. Scholarships to the university. You donate a whole bunch of money to the university. When they give away a scholarship, it's the interest that money has earned so that the scholarships can go on forever. Otherwise, you'd run out of scholarship money. Okay, sometimes maybe they don't give you all the interest it earns because you might have some bad years where the interest rates are really low. So they may try to figure out what's a happy medium so they don't ever let the principal go down. Or they just go back to the family and say, we're going to have to decrease the scholarship your great uncle left unless you'd like to kick in another $1 million. Okay, that's the way it works. Alrighty, so that would be living off the interest or just scholarship money. Okay, when you think of oscillating, what do you think of?
Goes up and down.
Going up and down. Okay, so what could happen with oscillating is it could go up and down and then start to approach a certain number, or it could just go crazy and just start, you know, this would be like a ball bouncing. It bounces and then not quite as high and then it kind of levels off like a little slinky kind of deal. Or you could just like, I don't know, send something crazy where each time it just starts going further and further and further away as it does, it oscillates. Okay, so those are your possibilities. All right, when you hear increase and decrease, there's a term we use for that. It's called monotonic. Monotonic. Okay, when you have one of these situations approaching a certain number, like this oscillating is getting close to this little number right here, we say it's approaching an asymptote. Asymptote, if it starts to approach a certain number. If I made this curve right here start to level off to a number up here, for example, you know your brain can only handle so many nonsense syllables over a period of time. Like if somebody rattled off nonsense syllables, there's only so many your particular brain will handle. Don't y'all ever play these nonsense games? Okay. Well, your brain will only, mine's down here, but yours is younger. Yours is up here, and you can only handle so much memorization over a short period of time of nonsense syllables. Or do you just have somebody challenge you and see how many you remember? All right, but that would be your asymptote if it starts to approach all your brain will handle. Or the fish pond can only handle so many fish before they die. Okay, these are asymptotes here. All right. So what we're going to do now is, based on this kind of information, see your y sub 0 is on your y-axis, and based on that and what your A and B is, we're going to be able to make a sketch of the graph. All right, now the rules for this, which I just call a little cookbook. Let's see what page this is in your... Okay, there's a little cookbook here on page 399. 399. And I'm going to help you see where this little cookbook comes from. And once you know where it comes from, then it's easier to remember how to graph. So this is going to be sketching the graph given the difference equation. A is not equal to plus or minus 1. You won't see any of those. That gets into that simple interest deal. Of course, A can't be 0, otherwise you have your little constant deal. It's never going to work anyway. All right, I'm going to help you see where this comes from and why these rules work, and we're going to sketch some graphs. Okay, so everybody got your page there so we can keep referring to it? All right, so let's take one of our earlier problems. I'm going to flip back to yesterday because we already know some answers. I'm just going to take one of those difference equations. Okay, I'm going to take the difference equation from yesterday. Y sub n plus 1 equals 1.06 y sub n plus 50. And we already know what that is. That was our savings account that we were adding 50. So we know the, oops, backwards for you, right? We know the graph's going to go like this forever and ever. It's going to be increasing monotonic. It's going to go like this forever. All right, so y sub n plus 1 equals 1.06 y sub n plus 50. Okay? And our y sub 0 is 100. We have to know this to be able to do it. Y sub 0 equals 100. And we started generating terms. So if we plotted all those, they would have just gone up, up, up. Okay. All right, let's go to our little cookbook here. It says, draw the line y equals b over 1 minus a as a dashed line. All right. Now, you may be wondering why they're going to start out there. All right, so let's recall the solution. Y sub n equals b over 1 minus a plus y sub 0 minus b over 1 minus a to the n. All right, so the first thing it's going to tell us to do is just look at the difference equation, find that b over 1 minus a, and let's do a little dotted line. All right, now notice where that is in the solution. What happens, we're just thinking ahead, we're using what are called critical thinking skills. What happens if y sub 0 is going to be exactly equal to b over 1 minus a?
0.
That term becomes 0, and y sub n is always going to be equal to b over 1 minus a, and what kind of graph do you bet you're going to get? A constant graph. All right, now look at your little cookbook. Plot y sub 0. If y sub 0 is on that line, the graph is constant, and the procedure terminates. You go, yay, finished. Don't have to go through the rest of them. All right, so that's why we're always going to start with that b over 1 minus a, rule 1. All right, so we're going to follow the rules. We're going to try to make a sketch, and the first thing we're going to do is look at that b over 1 minus a, which is 50 over 1 minus 1.06. So 50 divided by a negative 0.06 equals, what's that, negative 833.33? All right, I got a big break in my graph here. Negative 833.33 is my dotted line across the bottom. Okay? So the first rule said find b over 1 minus a and put a little dotted line in it. There's a chance this dotted line is going to be an asymptote that the graph would approach. But another word we're going to use, we're going to use some words called attract. It's going to be attracted to the asymptote, attract, or repel means it's going to get away from it as fast as it can. But we haven't gotten to that far yet. All right, rule 1, do our dotted line. And now we're going to plot y sub 0. So y sub 0 is equal to 100 here. So there's our first little dot. All right, since that little dot is not on the dotted line, it's not going to be a constant function. Okay. Now, rule number 3, step 3. It says, if A is positive, write mono, since the graph is then monotonic. If A is negative, write oscillate, meaning the graph is going to oscillate. Okay, you're going, well, I will never remember that rule. Yes, you will, because think back to the solution. A is going to be a number raised to the 1, 2, 3, 4 power. Okay, so if A is positive, when you raise a positive number to a 1, 2, 3, 4, 5 power, it's going to be positive, right? But what happens if you raise a negative number to a 1, a 2, a 3, a 4, a 5, a 6? What's it going to do? It's going to negative to positive, and that means it's going to oscillate. So this rule says when A is positive, monotonic, it's either going to always increase or always decrease. It's going to increase when A is bigger than 1 because you're raising a number bigger than 1 to a power. But if A is something like a half, what happens when you raise a half to a third, a fourth, a fifth, a sixth? It's going to get smaller, right? So then you'd start to go down. Okay, but not to that part yet. Okay, so if A is positive, it's going to be monotonic. So in our problem, our A is 1.06. So it's monotonic. So I usually write mono right here. That means that from the 100, it's either going to go up or it's going to go down. It's not going to oscillate anywhere. Okay, let's look at the next rule. The next rule says, if the absolute value of A is less than 1. All right, absolute value of A, less than 1. That means like a number like a half, less than 1. And when you start raising a number between 0 and 1, because absolute value of A less than 1, 0 to 1. When you start raising a number like a half to a power, that number is just going to get smaller and smaller and smaller. And when you start multiplying a real small number times something, like a half times 10, a fourth times 10, an eighth times 10, it gets smaller and smaller and smaller, right? And so when this is getting smaller and smaller, we're going to be attracted to that line B over 1 minus A. Because this part's going to get smaller and smaller, multiply times the smaller. So this little part's going to start to get real close to 0, and you're left with the B over 1 minus A. Does that make sense? You guys are good following this with me. Okay, so it will attract. If your A is big, absolute value of A is bigger than 1, this is like your 2 raised to the first, second, third, fourth, fifth. This number is going to get huge. You're going to multiply it times something huge, and that's added to this little B over 1 minus A, so you got something bigger being added to it. It's going to send it away. And then we're going to call that repel. It's going to repel that line. Okay, and they use the word repel. All right? So, A, 1.06 is greater than 1, so it's going to repel. All right, now we are not interested in exactly what every little y value is because we're making long-term decisions. What is happening? So if we're at 100, it's going to be monotonic and it's going to repel this line down here. How are you going to graph it? Up, 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 up. Okay, and so we have an idea what it looks like. Got it? Okay, let's go to the example we just did with our pitiful population. Go back to the difference equation. All right. Everybody okay? Can I flip the page? Slow me down if I need to slow down. All right, so we're going to go back to the population. Y sub n plus 1 equals 0.99 y sub n minus 1, and y sub 0 equals 70. And we already have our B over 1 minus A is equal to negative 100. Okay, I just pulled this off problem number 20 from 384 that we just did a second ago. Okay? All right, we already knew this population was dying out. We know they're going to be gone in 52 years. All right, but now we're going to pretend we don't know this. So we want to graph without plotting points. And that's the way you'd see it on a test. Sketch a graph of this without plotting points, just using the difference equation. Okay? All right. Now that we went through everything, let's don't look down and see if we can figure out what we should do. Okay, how are we going to use this y sub 0 equals 70?
That's where we start out.
Just put a little dot here, right? This is 70 million. This is your y sub 0. All right, now how am I going to use this b over 1 minus a?
Dash line.
All right, that's a very important dotted line because the graph is either going to go towards it or away from it. All right, negative 100, that's way down here. And we'll put a little dotted line. Don't forget your dotted line. B over 1 minus a equals negative 100. Okay. Now, the first thing we notice is that a
Positive.
is a positive number.
Monotonic.
So it's going to be monotonic. Okay, if you keep in mind where the a is in the formula, it's being raised to an nth power, so a positive raised to a 1, 2, 3, 4, 5 is always going to be positive. All right, if it were negative, it'd be oscillating. All right, now, this number a is less than 1, so we're looking at a fraction, 99 hundredths. And you can just even go down to like a half. I mean, just thinking about it. It is being raised to the first, second, third, fourth, which means that that is going to decrease, right? A small number here, so it's going to be attracted. Of course, since this is people, we know we can't go down to the negative 100, right? I mean, we're not going to have negative people. All right, so the deal is it would keep going down into the negatives, but this was a real situation, and so we'd have to stop up here at 0 because it was people. But if this was your bank account, no, stock market, excuse me, money in the stock market, and it would, like I just read in the paper this morning that one stock had gone down to 3 cents after announcement that they lost a case yesterday. That was in the day's paper. So there's went down, and it's going to start getting in the negatives of your pocket for sure. Not really, you're not going to have to pay it out, but you could run a business and get in the hole. All right, everybody got that? All right, let's try one that's going to oscillate. See if I can find a good one. Let's see here. Okay. All right, this is right out of the book. This is page 403, and this is going to be problem number 20 right out of your book. And it's y sub n plus 1 equals negative 0.6 y sub n plus 6.4. All right, and you are to sketch the graph. Let's see, what's y sub 0? Y sub 0 is 1. Y sub 0 equals 1. You're supposed to sketch the graph. Y sub n plus 1 equals negative 0.6 y sub n plus 6.4. Y sub 0 is equal to 1. You go for it. Be sure to use the word mono or oscillate, attract, or repel. Sometimes I'll ask a question on a test. Is it monotonic or is it attract or repel? Bits and pieces. Can I use your stuff today? Yes, I do. I have faith in you. Who's got it? Okay. I'll take my red pen and give you a big check mark. You haven't graphed it. You got to graph it. Okay, remember when you're graphing difference equations, it's dots, not lines. You just got to do dots. That was negative. Okay, I'm still looking. Okay, if you do your dots, I think you're going to be good. I think you're good. Good, 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 good.
Oh, yeah. That's what it would do. Like, go like that, and then eventually reach it like that.
All right, let's see how we're doing. And I want to hear only positives. Did you get it? What did you get? It's not monotonic because A is negative. Yeah. All right. A is negative. B is 6.4. B over 1 minus A. What'd you get when you just did that? 4? Okay, y sub 0 is 1. Put a big old dot there. All right. 4. All right. Rule number 1 is put a dotted line through B over 1 minus A. Okay? All right. Then we start thinking about A. A is what's being raised to the nth power. 1, 2, 3, 4, 5. A negative raised to a 1, 2, 3, 4, 5 is going to be plus, minus, and that makes us think of oscillating. Oscillating. It's going to jump back and forth. Okay. Now, the absolute value of A, is that greater than 1 or less than 1? Less than 1. Less than 1. So you got a fraction being raised to a power. What's that mean it's going to do? Attract. Now, it's going to oscillate around the line B over 1 minus A, and it's going to be attracted to that line B over 1 minus A. So here's the y sub 0 is 1. We got to oscillate about here, and then it's going to be attracted to it. All right, now, you're not plotting points, but I just want to point this out. If it's going to, like, this is your magnet, and it's going to jump around it. Notice this is 3 units down. So when you get an N at 1, wouldn't this next dot it has to be less than 3 units here? Because each time it's getting a little bit closer. So I don't know where it is going to be unless you actually iterated lots of points, but it can't be as far as y sub 0 is up to 4. So it's just got to be a little closer in. So I'll just make a little closer in. That's closer than here. Do you see what I'm saying? So then when I go to 2, that's got to be closer in. Okay, so we make it a little closer. And again, unless you actually plot points, you're not going to know exactly what it is anyway. Okay? How's that? I oscillated. Each time's a little closer. Mistakes that I saw as I walked around, and I need to point these out for everybody. You're not connecting the dots because N is 1, 2, 3. N is not real numbers. And if you connect dots, you're talking about all real numbers. Okay? Everybody good? Happy?
Yeah.
You can do it? All right, so tomorrow I want to be able to go back and answer questions on 10, 1, 2, 3, and 4. Be sure you've worked problems in the book. We'll sort of clean it up, and we're going to move into the textbook. Okay? Have a great day, everybody.